Welcome back. So in this video, we're going to explore Chapter 8 of Introducing Second Language Assessment. And in this section, we're going to focus on how to judge effectiveness of dichotomously scored items. So just as a reminder, we're talking about multiple choice, true, false, short answer kinds of tests where we have a clear answer. The kinds of tests that you could have scored automatically in a lot of learner management systems. They're simply marked right or wrong. So we're going to see how these statistical tools help us evaluate whether test items are working as intended. We're going to start off with item facility. And item facility tells us what proportion of test takers answered a particular item correctly. To calculate it, we're going to take the number of correct answers and divide that by the total number of test takers. So, for example, let's suppose we have 10 people who answered a test item and 2 of them got it correct. The calculation would be 2 divided by 10, which will give us 0.20. That means the item facility is 0.20, which means that 20% of the test takers got the question right. Now, let's pause for just a minute and see if you can calculate this on your own. I want you to calculate the item facility for item number 8. Then, based on your calculations, I want you to tell me what you can infer about this item compared to item number 1. So again, pause for just a minute, calculate item 8's item facility, and think about what that tells you about it in comparison with item 1. Okay, so if you said item 1 was much more difficult, you are correct. Let's look at the guidelines for norm reference tests in your textbook, and you're going to see that any item with a value under 0.3, and 0.2 is below 0.3, that's going to indicate an item that's considered too difficult. What does this score tell us about item 8? Looking at these scores, is item 8 an appropriate test item? Or is it too easy? Tell me what you think. Again, I want to remind you, this is in the context of a norm reference test. Because on a norm reference test, you're expecting there to be outliers. So a few students who got test items correct that no one else got correct, and a few students who got test items incorrect. But if we were looking at this for a criterion reference test, that score would indicate a potential problem because we're expecting in a criterion reference test that the majority of the students are going to do well on the majority of the questions. On a criterion reference test, we would want to be looking at the item to see, was it poorly written? Is there something ambiguous about the way the question was stated? Or maybe was the concept not mastered by the majority of the students, either because you didn't teach it well, or maybe they didn't study it. All right, so hopefully that gives you a basic overview of item facility, how easy or how difficult a particular item is. Next, we're going to look at point biserial correlation. And this statistic shows the relationship between how test takers performed on a particular item and the overall test score. So if you have a high PB, it means the item helps to separate out the stronger test takers from the weaker ones. To understand it, we first need to revisit the idea of correlation. So correlation measures the strength and the direction of a relationship between two variables. For example, between scores on 2 different quizzes. Let's imagine we have 10 students and they take a reading quiz and a listening quiz. If those who did well in reading also did well in listening, and those who did poorly in reading also did poorly in listening, we would see a strong positive correlation. Okay, so the relationships are the same in both of those quizzes. Good students did well on both, poor students did poorly on both. So on the scatter plot, we would see with each dot representing a student's scores, we would see a clear upward trend in the dots indicating a positive correlation, meaning the performance on one quiz aligns with the performance on the other. A negative correlation works the opposite way. For example, if students who scored high on a reading quiz made fewer grammar errors, while those who scored low made more errors, we would see a downward trend, a negative relationship, showing that while one is moving down, the other is moving up. All right, so correlation values range from -1 to +1. A value of +1 means a perfect positive relationship. -1 means a perfect negative relationship. And a value close to 0 means there's little or no relationship. An item with a positive point by serial is very useful because it means the higher scoring students generally got the item right, while the lower scoring students generally got it wrong. And that's exactly what we want. But if an item has a negative PB, that is a problem because it suggests that the lower scoring students are the ones who got the item correct, while the higher scoring students missed it. And an item like this would reduce the overall reliability of the test. We doing okay so far? Now, when we look at items with point by serials near 0, that tells us they don't discriminate at all between the more proficient and less proficient test takers. So even though these don't actively harm reliability, they also don't really tell us anything about the test takers. They're a waste of the test taker's time. All right, so what counts as good? Generally, items with PBs of zero point 0.3 or higher are considered to be effective. Negative PBs are red flags and often indicate that something is wrong with item design or scoring. And PBs of 0 indicate items that we might want to consider getting rid of because they are a waste of time.